Welcome to Top Shelf Tech. Today we're here with Dr. Ken Urquhart from Zscaler, and we're going to be talking about 5G and really how that will change the world, but quite importantly as well, how we're going to secure it. So Ken, welcome along and thanks for joining us. Would you like to start by just giving us a little bit of an introduction to yourself and your background?
Yeah, hi Jeremy, and thank you very much for having me here, and hello everyone from the great American Southwest. I'm Ken Urquhart. I do 5G strategy at Zscaler. I have been in this business a very long time. As an executive at Sun Microsystems, IBM, and at Microsoft before coming to Zscaler. I've been in cybersecurity since 1988. I helped install one of the very first firewalls way back when the internet worm was the only thing in town.
Wow. Quite a career, and now you've landed yourself in a really interesting field, very quickly developing field of 5G. And I think the kind of world awaits with bated breath to see what 5G is going to bring us. And for our audience, which is mostly business orientated, what are you seeing with 5G, and how, and what are the applications that we'd expect to see rolling out?
Sure. Yeah, let's talk about three things. And then three more things. First is how business people are talking about 5G. And they've been talking about this for several years, but the numbers have stayed remarkably consistent. More than 2/3, almost 70%, said they think 5G-enabled services are going to be transformative to both their business and their customers. 73%, almost 3/4, say the Internet of Things is going to be revolutionized by 5G, which is a big statement. And 85%, something like that, said 5G networks are going to be transformative and will have lasting impact on their business. Those are pretty high expectations.
Very high expectations, absolutely.
At the same time, they say, and 5G will make me more secure than, say, 4G, 3G, Wi-Fi. That's kind of true for a given value of secure. The point being, your network can be made secure based on the standards being put forward for 5G. It'll make you far more secure than 4G and 3G networks. It will make you more secure, as claimed, than, say, Wi-Fi. Trouble being that if you get the configuration wrong, that's like 80% of the cybersecurity breaches you're going to have. And while it secures your network, it doesn't secure the workloads you put on it. The fun thing is, yes, we can make the network secure, but you're responsible for the equipment you attach to it and the workloads you put on it.
And if we talk about some of those workloads, you talk about lots of customers are saying this is going to be absolutely transformative to their business, and we've heard that with lots of things. We've heard data will transform our business, and big data is coming, and it's going to
everything's going to transform your business. The question is when and by how much.
Yeah.
And what's the cost? Remember, these are business. We're talking to everybody out there is asking themselves, how much is this going to cost me? And again, the answer is it depends.
And so the industries that you're speaking with, what are the applications that you hear coming up time and time again around 5G, and where they feel that they're going to get transformative change?
Yeah, and everything. Just to take a step back, my other three things is, to understand the use cases, you have to understand what 5G is trying to bring you. And for me, I summarize it with three words. It's fast, it's live, it's massive. Fast. Think of it as fiber optic speeds wirelessly at huge amounts of throughput. Think of it live, meaning almost real-time computing. You can have servers sitting very close to where you're using your devices with radios in it to get very fast turnaround. Things like AI inferencing at the edge, things like augmented and virtual reality are all lit up by this combination of very close by edge servers running on 5G networks. Finally, massive. What does that mean? Think about 1 million devices per square kilometer without your speed dropping. That's huge. Wi-Fi, you're looking at thousands of devices per endpoint. 4G, LTE, hundreds of thousand devices. Now with 5G, looking at millions of devices. That lights up smart cities right there, because it was always, I can't quite get enough devices on per square kilometer to really instrument out the area and really understand it and really make it responsive to the needs of the citizens and the businesses operating in that area. And the last thing that doesn't fit into that is they're looking at radios for 5G are using 1/10 of the energy of 4G radios. So that means things like you've got IoT devices running with a 10-year lithium ion battery. Right now, you can get a flow sensor for fluid in a pipe. You can attach it to the pipe. You can bury it and put the antenna above ground, and you can basically forget that device, depreciate it, and write it off.
10 years.
10-year lithium-ion batteries. Now, admittedly, that device really has low power consumption. It's not transmitting continuously, but you've got a 5G sensor without wires.
So a lot of what we're talking about is where technology is going to interact in a much more meaningful way with the real world, whether that's, sensing things, actuating things, displaying things in real time and giving feedback. And, I think with that, there's some great possibilities. There's also some great implications, right? Because you can either observe or control a whole lot more than you ever could before. And I think this is where, the topic of how, you're talking about 1 million devices, you're talking about really low latency, and you're talking about quite high impact applications. The approach to securing 5G seems to be logically quite different than to probably how we've secured network assets in the past, or at least for certain applications. So how are you thinking about security in a broad sense? And you already talked a little bit about being more secure on 5G, but how are we thinking about securing these applications?
Yeah, and I just want to say more secure on 5G. Let's just peel that back a tiny bit. Yes, a 5G network is by design more secure than a 4G network. On the other hand, the rule is when you've got a 5G network and something doesn't happen right, you fall back on the 4G network. So if you've got this dual networks, which is recommended you have, you're still carrying all that baggage for the insecure, relatively less secure 4G network. That's one. The other one is, given that speed, the data throughput, the fact you're going to be running, real-time AI, real-time inferencing, real-time augmented and virtual reality, things can go real bad really quickly if you're hacked. And that's something people need to remember. We're talking about, I'm going to be, like the 2/3 of the spend in private 5G predicted through the next couple of years is going to be manufacturing, transport and logistics, energy and utilities. Energy and utilities, something going wrong, getting hacked, pipeline shut down, energy doesn't get delivered, people can freeze, people can overheat, bad things can happen. Logistics, trucks don't go where they're supposed to go. Manufacturing, robots hacked to assemble something very carefully and just wrong enough that it completely ruins the entire production run. Or let's say you're assembling rocket engines and they all explode on first use because they've been hacked and a small change was made. Those are the kind of things that we're talking about. Things go bad very quickly. So what do you do?
Yeah. High stakes, high reward, isn't it?
Yeah, it absolutely is. And in the old days, you'd say, okay, I put firewalls. I'll do all connections over remote VPNs. And you say, yes, you can do that. They come with overhead, latency issues. They sample streams. They do things that can be very effective for you. They also can get in your way. They also can have integration and configuration and updating issues. You have to stay on top of it. And that's part of the expense of trying to secure any network. There's a new approach called zero trust. It's something Zscaler's been doing for 15 years. So therefore, it's one of those overnight sensations that's been a long time coming. Certainly to have the industry understand what it is. It represents a new way of thinking about it because it says, hey, let's just say, what do I have to do to operate securely if my network is already hacked? If workloads are already compromised, how do I continue functioning in that world effectively, safely, and securely? You don't start with the Firewall is us, them, in, out. And you design that, you get with a siege mentality, which says your outside attackers only have to be successful once to breach you. You have to be successful 100% of the time in order not to be breached. And once you get in, it's like the old thing about beehives and wasps. A wasp comes in the front of the beehive. They are attacked mercilessly to protect the hive. A wasp eats its way in at the back of the hive and gets inside. You pretty much assume you're allowed to be there, and they go about their business ransacking the hive without being attacked. So this us and them, in and out, just it is an invitation for trouble. You say there's got to be a better way. And one thing we say is, yes, it's called zero trust. What does that mean? You don't trust anything, anytime. And there's 5 pillars to this. There's identity. Who are you? What's the IoT device? What's the workload sitting out there? Prove to me you're who you are. And I mean, prove to me continuously who you are. I don't just, you authenticate once and I say, okay, you can have free run of the place forever. No, you come back and you re-authenticate, you check what they're doing. They start doing something a little odd. You go back and force them to authenticate at a higher level. Don't trust. Just assume they're malicious waiting to do something. And you're just watching to make sure they don't. Second, devices. Users use devices. Devices talk over arbitrary networks to a workload. That device, is it a device we expect you to have? Is it behaving properly? If it says, you, Jeremy, you have a laptop, you're running Windows 11 on it. The laptop is a Dell running a Xeon processor. Is that what's happening? Is that what's connected to the network? Or are you really kind of talking like you've got a Linux box or you've got a Mac? If it is, that's not you. That's not who we're expecting. And you get very suspicious about that. Finally, network. Where are you going? You can cross any number of arbitrary networks. I don't care. I just need to know where you're going. And then are you to the work application? Are you allowed to touch it? Are you allowed to interact with it? And the application, is the application what it's supposed to be? If it says that, if we're told that application is an Oracle database, does it behave like an Oracle database? Are the only ports open on it what I expect from an Oracle database? Is it exchanging data using the protocols Oracle database uses? If it isn't, it's suspect. And you know, that database, it's got information engineers are allowed to touch. Great. Why is it suddenly trying to talk to the finance system? That says that's not normal behavior. I don't trust that. And I can cut it off the network. So those are and then finally data, everything encrypted and everything inspected. When possible, 100% packet inspection. So you know what's going. Nothing bad gets in, nothing good gets out. You're running data loss prevention, you're running malware detection, you're running real-time sandboxing as needed. That's kind of at a high level. And all that is supposed to be almost invisible to you. So there's these 3 foundational principles. One is visibility and analytics. You know what's going on at all times because you're watching everything. Then there's automation orchestration. You using the system should not know you're using it. It should look like you're just accessing stuff over the internet freely without obstruction. And finally, governance, a whole pile of rules, like I've been alluding to. You as the organization set your rule set. You say, this is what I mean you have to authenticate with for me to trust you. This is how devices have to identify themselves for me to let them on to attach to applications. And here's how applications have to behave in order to stay on the network and be available. And once you do that, you don't care what network they're traveling over. That network can be breached. You don't care. That's the beauty of zero trust, operating in a compromised environment. And I don't mean like it has to be. It's just you can't verify the security level on that networks that you're crossing over, which means you can now suddenly won't go over anybody's network because you don't have to verify how secure it is. Now, I've talked a very long time. You've been very gracious letting me talk like that.
Yeah, and I think we'd see there's been great development around these zero trust and businesses starting to implement this over the last couple of years, and we've seen now good understanding I think about how you might apply it to laptops and workloads running in the cloud. If we bring this into the 5G arena and we're talking about devices that aren't necessarily going to run a agent that can, direct traffic and do these sorts of things, or maybe they will, maybe they won't. And we're talking about edge computing, and you don't have the luxury of going out via, a cloud environment. How do you apply zero trust? And in fact, what's Zscaler's approach to securing that? Are we thinking about the same sort of, hey, we secure the end device and the edge computing, or are we thinking about we stop stuff outside of that? How do we bring that zero trust world together with the 5G world?
That is an excellent question. And our solution is we actually can integrate directly with 5G cores. We can integrate with the antennas. We can integrate with the edge servers. No problem. We also have a version which runs locally. So when your data needs to stay local, talking only to the edge, we can take care of that too. Now, I'm not announcing right now these product suites are, fully available today. They are being available this year. Customers are quite happy. If you have a Zscaler account already, talk to your sales rep, say you'd like to try it out and see what happens. If you've got private 5G, absolutely, we can come and show you what we've got here. And it integrates with the existing systems.
So we're talking about probably, I think you mentioned Zscaler. You can run at the edge, right? There's the ability to do that stuff within the Zscaler world, and which is really useful for all sorts of applications. But then talking about embedding in antennas and embedding in the 5G cores. So there's presumably quite a vendor partnership play happening here as well, where Zscaler and 5G cores and 5G services will become quite inherently packaged. Is that correct, my assumption?
Well, remember, we are a software-only solution, meaning you can deploy us in your computing environment, meaning you can deploy us into your edge servers. You can deploy us on endpoint devices when they're suitably big enough, like they're Linux, Android, Windows, iOS. When you're not, we have another solution to handle what I call very, very limited compute devices like temperature gauges, vibration sensors. There's another solution for that runs locally. At the same time, you can do things like string your factories, each individual factory with private 5G. You can then protect all of them, and they can all interact and exchange data through the cloud. There was another point I wanted to make. Yeah. A lot of the data is meant to stay local. In fact, I think I've seen Gartner, I believe it was Gartner, hope it was Gartner, said that 75% of the data we're going to be generating as an industry is going to end up being processed locally at the edge. Now, it's certainly going to be true for lots of 4K, 8K data that's going through image recognition systems. Why do you want to ship that back to the cloud when you can do it locally?
Yep, and I think just latency is something that we've discussed all through this conversation, and we're talking about, I guess, where we're transporting data, where we're holding data. Now, Zscaler from the earliest days had a very big focus on latency in terms of both how the solution was designed, and that the ability to process network traffic at almost line rate speeds and apply a whole lot of security stuff that typically happens in sequence and series and can be very latency intensive. So Zscaler's always had a big focus on that, to the extent that from those early days, there are even SLAs around how quickly your data would be processed. Now, if we apply this into the 5G world again, just how critical is that latency? So and VR and AR is one of the things that we've talked about, and you've got concerns around motion sickness. How does security and latency kind of come together in this 5G world?
Man, you know our products really well. I mean, you're doing this better than I am. This is fantastic. Thank you. Yeah, the thing about latency, about edge compute, is to, first of all, handle huge volumes of data locally that it's just too cost prohibitive to ship to some workload sitting out in the cloud. That's one. Second is when you have the ultra low latency, near real time workload, you have to have, like when you're controlling a robot locally and it's responsible for doing a lot of very fine work, but it can't have the processing right there with it. you'll want it in the, like a server room in the back of the factory where you have really high energy crunching going on. And by the way, there's a lot of edge servers now. We're seeing a world where we're getting away from air conditioned closets towards sealed liquid cooled systems where, they don't care whether it's -40 or whether it's 120. And these are Fahrenheit, -40 C, or it's, well into the 40s C. They'll be able to soldier on without air conditioning. That's a huge bonus for the factories, and that's coming. In fact, this year, edge compute is, people haven't got quite there yet. 5G has been proceeding. Like last year, the big thing at Mobile World Congress, the big place, all telcos get together to show their wares and talk about the industry. It was held in Barcelona just last month. But year before, they talked about the speed of 5G was showcased. This year, edge compute was showcased, the ultra low latency. And why? Well, it was predicted at least 5 years ago, possibly longer, that the first big use case for 5G is going to use the speed. So streaming a video, getting it from devices or getting it to devices very quickly, so it's ultra high def. They said the next thing is going to be AR, VR, augmented virtual reality. And that's now what I'm seeing. That was massively featured. And that requires very low latency compute loads that turn the data around very quickly, because when you don't, you get motion sickness. So we're on path for this. Then the massive scaling will be coming within the next couple of years as the specifications around it get finalized at the 3GPP standards bodies, which owns the 5G specifications. But the other thing is, people aren't quite ready to understand what low latency is. A lot of places have not really had that idea of experimenting with it. You'd have a robot, but they have the server right there with it.
Yeah.
Now we say you can take all that off the factory floor where it's out of harm's way, put it in the back room, utilize all that scale when you need it, instead of having to put a supercomputer at the base of every robot. Supercomputers in the back room, robot uses what it needs when it needs to use it. Cost savings right there.
Yeah.
And so what we've seen, like with edge, is people are amalgamating workloads and putting them in the edge compute. Latency isn't that big a deal. Throughput, bandwidth is. We're getting to where now we're seeing the ultra low latency rollout, and we're going to see these big use cases in those three buckets. As I said, we've got manufacturing, transport, logistics. Moving things about, stocking things, getting it where it needs to be. Then energy and utilities. And that leads to sort of like the big 6 use cases they're looking at across all of these, which is automated guided vehicles, portable robotics, reducing labor costs, ensure worker safety, accelerate your build design process, smart grid, tons of sensors placed, watching how the energy grid is being used to make sure the right amount of power gets to the right place at the right time. So lots of sensors. Asset tracking. Where's my stuff? Being able to say when that truck is going to arrive can make a huge difference in how you're planning, how much crew you bring on, what you have to do, how you can optimize for costs, reduce track loss, stolen items, that kind of things. There was this case within the industry used with IoT and tracking on trucks. And the interesting benefit is they discovered that the trucks that tended to stop somewhere on their journey for a half hour, 45 minutes, were typically the trucks where stuff disappeared from. And being able to tell when the truck stopped and where it stopped went a long way to figuring out who was doing what. So, again, it's an interesting use case. So we got robots, we have drones, energy companies love that. They can do more inspections, see what's going on, pinpoint problems faster without having a bunch of crews running around over a huge area looking at pipelines. Remote controlled cranes and machines. There's already ports where there's 5G used to load and offload containers. So the workers are not up in the cranes. So when there's high winds, rain, storms, possibility of risk to the life of the crane operators, they can keep operating. Predictive maintenance, when's it going to break? Interesting fact, a cheap little sensor that picks up vibration and one that picks up sound of any rapidly rotating device, listening to it and listening to variations in the sound is usually the first indication that unit is breaking down or that unit needs maintenance. These are cheap little sensors you can do. Put the batteries on, slap them down. In a factory, the biggest problem you got is those cables that carry networks are not life-threatening if you break them. So when you got power cables, those things are thick and massive and meant to handle a lot of punishment, stepping on, hitting them, dropping things on them, because if they break, people can be electrocuted. Ethernet, doesn't matter. You're not going to kill someone if you break it. You're not going to kill someone if you cut into it or grab it. And so those things are breaking all the time, and they've got to move around all those machines in dangerous areas with moving parts and have to be secured. And the people who install them have to move around those machines, which typically are going to be keeping running for efficiency. And that's dangerous. Imagine being able to not have to route cables in that complex world. Walk up, slap a battery-powered sensors on from a safe direction, walk away, the machine's all done. And no one's going to step on cables because it's got a 5G radio on it.
Yeah, I think running across all those industries, there is just a huge amount there that that's I think you can see both the positive implications and, as we've discussed, the sort of potential impacts from a security perspective. So that's been really useful to hear. I think both sides of that today, Kim. So really appreciate your time in joining us. Were there any final thoughts that you wanted to leave the audience with? Around the space, around Zscaler, where you're going?
Remember, private 5G in a factory, in a business case, is going to be also there with Wi-Fi, traditional wired, many different networks, packets moving over them. A real zero trust design doesn't care the network it's going on, meaning you can have true zero trust protection on a 5G network without ever touching the 5G network. It's not necessary. You can protect endpoint to workload, edge, cloud, data center, because true zero trust, like Zscaler has, is an overlay. When you want to then move to protect the actual infrastructure, the network itself, in addition to your applications and endpoints, then there's how do you integrate with the private 5G network and provide security. And there's actually multiple ways of factoring that with different security based on how you want the private 5G to deploy. And if you want to do some collaborative split with a local telco just for cost reduction or scale, or the benefit of not having to hire administrators for a network, because 5G networks require people who understand how to administer telco networks, and that is not an inherent skill of an IT administrator or a cybersecurity group in a corporate setting. It's new skills to learn. And when you try to do all of that, in addition to also the work to protect the IT networks, there is a hill to climb. There is a steep learning curve. And for that reason, a lot of private 5G installs are going with one of these hybridized split versions where they share the core with the telco and they have pieces of the network installed locally. And that gives them cost savings, reduces the burden of administration, and makes it faster to implement. So you're going to see this wide range of deployments. And I'm happy to talk to anyone out there who wants to get hold of me and say, tell me about it. How can I do this to optimize it in my business to meet my goals without having to spend a fortune or have to hire a duplicate team to handle IT or a telco administration in an IT world? There's still bumps in the road as people adopt these new technologies. And if you think this is hard, wait till companies try to adopt private quantum computing. That's a whole different skill set you got to pull in.
Yeah. Oh, that's a very useful insight to leave us on, I think, around just that mixed mode of operation, right? And I think we see more and more of that need to collaborate between businesses to deliver cost-effective, high-tech solutions. So yeah, that's definitely interesting, and maybe we'll have to have you back to talk to us about quantum computing at some stage, because that's certainly something I'd love to learn more about.
As I tell people, my education is in physics. I have 3 degrees in physics. And I'll just tell you right now, most people trying to talk to you in a business sense about quantum computing do not understand what they're talking about. It takes decades to fully understand the subtleties of what you're trying to do. And mostly, I don't even understand presentations on quantum computing because the person giving it does not have the depth of knowledge necessary to make something very complex simple enough for a business person. No, look, this is what it's all about. If you can't explain what you're selling, nobody should be buying from you. And if you can't communicate to a business leader the value to their business in a way that may not be entirely right, but isn't completely wrong and gives them a framework to think about it, you're not going to be successful. And yet, kind of seeing a lot of that happen these days.
Yeah. Well, yeah, I mean, it's another new frontier, isn't it? So, look, thank you again very much for your time today. That was a really interesting conversation. I think we probably could have talked, and you mentioned this to me at the start. We could talk for probably hours on this subject, maybe even days. So, look, appreciate you condensing a whole lot of knowledge into 30 minutes for us in the audience. So, thank you very much, Ken. Appreciate you joining us, and I think that you offered people that to reach out to you if they want to talk about 5G. So I'm sure that's something that everybody will appreciate as well. So thank you for your time.
You're most welcome, Jeremy. Thank you for having me. Thank you, everyone. I hope this was interesting and informative.
Great. Thanks, Ken.